Hello everyone. In today's lecture, we are going to move on to a new topic, and which is also an exciting topic, neural network for deep learning. Actually, the neural network can do both classification and regression. Actually, the neural network, the basic idea tie together several ideas from our previous lectures, like linear regression, perceptions, logistic regression, assembled learners, and also the estimation commonly used the stochastic gradient descent algorithm, which we already covered before, but specifically it requires some computation techniques named backpropagation, which we will give some introduction in today's lecture. And in this course, we just give a brief review and the basic introductions about the neural networks for deep learning. If you wanted to know more details about deep learning techniques, we have another course called Deep Learning for Data Science, where you can where you will spend the whole semester to learn these deep learning techniques. The neural networks, actually, this is not a new tool. It was rose to fame in the late 1980s. There was a lot of the excitement and a certain amount of the associated with this approach, and they have several names in history. For example, like neural information processing. So actually, the idea of the neural network is not new, but it went through several they called AI winters in history. One of the famous story is that deep learnings, these techniques, this behave similarly like using the perceptions like what we introduced in the first few classes. They said the deep learning worker enthusiasts claim that this machine can be powerful, right? But there is a small task this machine cannot do. There is a XOR, a logic operation, which means if you have two variables, you have x1 and x2, and each of the variable has two category input, 0 or 1. If they are both 0, it gives 0. If either gives 1, so x1 equal to 1 or x2 equals to 1, they equal to 1. But if they both equal to 1, it gives the output 0. So this is known as XOR operator. But think about how can you define a support vector machine or perceptions to classify this case. Can you find a linear line to separate this case? For example, here, no, right? If you have a line here, you have two ones, so this case is misclassified. If you have a linear classifier like this one, you misclassify. If you have a classifier like this, you misclassify. And it seems that your deep learning machines cannot even do the simple jobs to classify these cases. So, and there is a book about what can there is a book about devoted to the things perceptions cannot do, and this is one of the most famous example. Well, actually, later on, I will show you that by using the deep learning techniques, we can do the job. We can classify such scenarios. And actually, the neural network resurfaced into became popular again. Actually, is after 2010. Actually, it's so it's the original idea goes back to 1980s, before 1980s, and after 2010, okay, the neural networks resurfaced and get a lot of popularity now, and everyone knows the powerful of the deep learning, like ChatGPT. And now they get a new name. It's called deep learning. Okay. But these tools, actually, the idea of this tool is not new. It's people kept doing this research for years. But many and this deep learning get great successful, like in the classifying images, video classification, speech, text modeling, processing, and many enthusiasts in this deep learning area still believe that the major reason for this great success, is the availability of ever large training data sets, because we are living now in the big data era now, and made possible by the wide-scale use of the digitalization in science and industry. And in today's lecture, we just give you some basic neural network structure, deep learning, and go into some of the specification for some specified problems. We're also gonna cover a little bit about the convolutional neural network. Like CNN, for image classifications, and recurrent neural networks. This is called the RNN. Okay, and next I'm gonna give you some simple examples of the neural network. Okay, so maybe let's give you some solutions. How do we use a simple neural network to train the classifier like this one, which linear? So, and then people start to think, oh, if the linear function does not work, can we, for example, we have the two input, right, x1 and x2, and we could give some linear combination, linear function, of x1 and x2. Okay, and we can get another linear function of x1, x2. Okay, so and then maybe we can also use a to use this as input and to train another, to get another function. Okay, to get another variable and to create another linear function. And then we predict the z value. It's either 0 or 1. But the linear function is linear transformation of the linear function is still a linear function. So a linear combination of a linear combination of linear functions. Is still linear. It is still cannot separate the case like this one. Separate like this one. 0, 1, 0, 1, 1, 0. Okay, which maybe we need some sort of the nonlinear separators to separate 0 and 1. Okay, actually, we needed to get some non-linearity. So besides using linear functions of the kind of input variables and linear transformation of the linear combinations, so the idea is we can add some nonlinear transformations here. Actually, after that we can construct a machine can separate this case. So I'll give you a solution here. So if input is x1 and x2, okay, we construct a linear function of x1, x2, which is given by 30 minus 20x1 minus 20x2. Okay, 20x1 plus 20x2 minus 10. But this is still linear transformation. We want to get some nonlinearity. So one simple way and one of the most popular way is we just apply the logistic function. Okay, so here S x is logistic function. So which, if you recall, 1 plus, when we do the logistic regression, we have the e to the power negative x, right? Logistic function. And in deep learning, we call it a sigmoid function. We call it a sigmoid. Okay, if you recall, if we have function, logistic regression function, Sx equals to 1 over e plus e to the power negative x. Do you remember the function can take any value as input, right? X can take any value, but the function value will, if it goes to negative infinity, it goes approaching to 0. And if you take the positive infinity, we get a 1. Okay, so for example, if we get a For example, if we plug in x1 equals to 1, x2 equals to 1, how much we get? So if this both equal to 1, so negative 20, negative 40 plus 30, this equals to s negative 10, right? S negative 10 will be so negative 10 is a small value here, right? So the sigmoid function will give you a value close to 0. Okay. On the other hand, if you plug in 1 and 1 to here, so we get a 40 minus 10, we get a 30. So S30. So S30 is a relatively large number in the logistic scale. So it will approximately gives you a value equals to 1. And okay, after applying this activation function, we find another linear combination of this output of the first layer. We get the second combination, which is given by S 20. So this give us, suppose we call this V, we call this W. So 20V plus 20W minus 30. Okay, remember previously at the first layer, if we plug in x1, x2 equals to 1, we get 0 and 1, right? So if V is 0, W is 1, what do we get? We get S negative 10, right? So this will give us a value, so it's negative 10 close to 0, right? Which did the right job, right? Do you remember in the XOR function, if we both x1 and x2 equals to 1, we should predict value equals to 0. Okay. Actually, let's do another scenario. If x1 is 0, x2 is 1. So I'll use different color. If x1 is 0, x2 is 1. So it's 10. So this gives S10. S10 is big number, right, in the large scale, so this equals to 1. X1 is 0, x2 is 1. Okay, we get also S10, right? So which is also a large number, so this value is also 1. And in this case, we both have the 1. So, and 20 plus 20 minus 30, so we get S10. So which give us a value 1. So which matches our XOR function. So by using you can also verify the other cases. Actually, this function gives us the output as x1 XOR x2. Okay. So, but without this nonlinear transformation, you cannot do this. I think with this deep learning setup, we can first solve some challenge in the history, very simply. So actually, this gives us some basic ideas of the deep learning. Okay. In next video, I'll give you more examples.